Hey everyone, you did a lot of discovery in class today. You learned even more a bit about it in extensions today, but now we're just going to solidify everything for you. We're going to kind of work our way from the bottom up around this entire foldable. It should not take too much of your time, but please make sure you're listening in addition to just like watching and copying. So the first thing we're going to start with is corresponding parts. When we say corresponding, that means things that are in the same position. So like if you're in a desk in our classroom, the corresponding person would be in the same exact desk above you in the classroom above us. So let's go ahead and open up this flap, and we'll talk about just this section, then we'll need these figures in the middle, but not quite yet. So it says corresponding parts are the parts of a polygon. A polygon is just a shape that are in the same position. And again, if you're in a desk, the corresponding person to you would be in the desk above you in the other classroom in any different two-dimensional shapes. What we're going to do is we're going to color each of the corresponding parts of the triangles the same color. So please prepare 3 colors. I have pink, orange, and blue highlighters. Let's look at our triangles. We've got a little triangle and we've got a big triangle. Notice that the little triangle is triangle ABC, and the big triangle is A, and then it has an apostrophe on it. We call this A prime. So the way that we say this is A prime, kind of like how we're prime time. This indicates that this one is the new one. This is our new triangle, and this is our original. Now, let's identify corresponding sides. If we look at side AB on our original, what side in our new is in the same exact position? Hopefully you said A prime, B prime. They're in the same position because they're both on the left-hand side. They both are between A and B, and they're both standing sideways. Our triangles are oriented the same way, so it's easier to tell. Can you tell me what corresponding side is to AC in our new figure? Hopefully you said A prime to C prime, and you would be correct. So those two are corresponding sides. Last but not least, we have BC. Oh, wrong color. We have BC, which we're going to make orange, has a corresponding side of B prime, C prime. Now, these corresponding sides are good to know once we get to this side of the foldable. But to know what a corresponding side is super important for kind of all of your math from here until geometry and algebra 2 even. All right, so now we've talked about corresponding parts, which are pieces that are in the same position. Let's close this flap and keep this one open. We'll close these two so we can focus. We're going to talk about scale. We will mention it here today, and we will talk about it more on Friday and Monday. A scale tells us how the measurements of a scale drawing or model represent the actual measurements of the object. And here is an example of a scale. Say you have a blueprint, which is like a diagram of a room. We can tell you that 1 inch could equal 3 feet, and in this case, 1 inch represents 3 inches. On a map, you'll often see something like 1 inch equals 30 feet, or 1 centimeter equals 1 mile. These are all scales telling you what the smaller version in front of you represents in real life. This would be the scale side, so like the blueprint or the model, and this would be in the real life side. Again, we're going to talk about this further Friday and Monday, but for now we're just mentioning it. Let's give this one a close. And now this is really what we focused on in class today, scaled copies. In class today, you should have worked with your group members to discover that a scaled copy is just a copy of another figure where each of their lengths was multiplied by the same number. Always multiplication, never anything else. Always multiplication, And that number has a special name, which is a scale factor. You should have also discovered that today, which we'll talk about down here. A scaled copy, and I'll open this up here to show you, looks nearly identical to the original. It will just be bigger or smaller. A scaled copy, its sides are in proportion. So let's add that in here. Sides are in proportion. What that means is that each of these sides were created by multiplying by the same number. AKA, we use the same scale factor, and it has a scale factor. So a scaled copy has an original, a new. The new one can either be bigger or smaller, and the sides will be in proportion or proportional. We will explore more of this tomorrow, and you also should have done a bunch of it in extension as well. The scaled copy is created using a scale factor. So let's talk about our scale factor. Today during class or extension, you should have discovered that we can find a scale factor by taking any one of the sides and writing them as a ratio of the new over the original. A good way to remember that is N over O, and Miss Frailer always likes to say, if I'm telling you no, it's the scale factor. New over original. All right, let's open it on up. The definition of a scale factor is the number each length of a polygon is multiplied by to create a scaled copy. Do you see how they're related? A scaled copy was created by a scale factor, and a scale factor is used to create a scaled copy. So let's go ahead in our two triangles and decide, well, what is our scale factor? We know that the scale factor is found by doing the new over the original. So let's pick a side. All right, let's pick 1. And what is 1's corresponding side? Because when you do this, you got to do corresponding sides. Otherwise, what's the point? We have 1 and 3. So our new length was 3. Our original was 1. And can we simplify that? Well, we can't simplify that as a fraction, but we do know 3 over 1 is just 3. So right now, we think our scale factor is 3. Now we can use our scale factor to find the length on our new shape. Because our scale factor said, all right, I took 1 and I multiplied by 3 to get 3. So here, I'm going to go from 1.5 to its corresponding side by timesing by 3. So what is 1.5 times 3? Well, it's 4.5. So the length of the corresponding side on the new triangle is 4.5. Now, if this is all a bit confusing, don't you worry. We're going to be working on it for very many days. Another thing you should have learned about scale factor, which we'll put on the front, is that if your scale factor, so I'll put if your scale factor is greater than 1, it's an enlargement, meaning it gets bigger. And if your scale factor is less than 1 but greater than 0, aka it's a fraction that's not improper, it's a reduction. And that's because if you take like 1/3 of a number, it's essentially just dividing by 3. All right, this is a little wrap up of everything you should have discovered in class today. Again, we're going to be working on it for very many times, but the gist of it is whenever you have a scaled copy, you have an original and a new. To find the scale factor or to see if they are truly scaled copies, you can check each corresponding side to see if the new over the original is the same. All right, good luck everybody. Have a good night.